In this video, we're going to create a camera controller in Unity. This camera controller is going to be very basic and it's just going to follow the player around, but so this is going to be a pretty short video. Now, this video is not a continuation of the top-down movement video. All of these videos are completely 100% standalone, but I'm going to use the top-down movement script so that I have something to test the camera out with. So, to start this off, what we're going to do is, if you haven't already, it's a good practice to create a script folder. We'll see here that from the last video I did have a scripts folder here, but if you didn't already, you'd right click and then click create folder and then type in scripts. In the other video that I'll stop referencing now, we talked about how you add components to a game object. There's a bunch of ways to do that, but the number one way would be to, in my opinion, have a scripts folder, and in the scripts folder, you right click and then click create and then mono behavior script. The reason behind this is the other way is just to go on your game object and then click add component and type in something new like camera controller. And this would make a new script called camera controller. But the issue with this is any scripts you create this way are going to automatically be placed in your assets folder here. And for good project management, you should put it in the scripts folder. Even better, if you're working with other people, everyone should have their own folders and then their own subfolders. So you shouldn't ever be doing it this way. Okay, let's say we have a scripts folder. Again, this video is standalone, so we're going to start ignoring the player now. We are going to make a camera script real quick. So in our scripts folder, we're going to right click, click create, and then mono behavior script. We type in camera controller, which is a little misleading because we don't actually control the camera, it controls itself, but that's still like the standard. Inside this camera controller, what we're going to do is we're going to write, this is actually probably going to be the shortest video on this channel. This is very, very simple. There's maybe like 5 lines of code. The first thing we want to do is talk about the difference between void start and void update. Void start is for writing code that should only happen once at the very beginning of the game. It's like setting things up, like player health or position of enemies or something like that. Void start is for things that will happen every single frame, like checking inputs, moving a health bar to the correct position, updating the player's health if they're poisoned or something like that. It's something that needs to happen over and over again. You wouldn't put code that like set a player's health to their max health in update because it would reset their health every frame. Things that set things up should always go in start. In this camera controller script, what we're going to do is we want it to follow something. We want it to follow the player probably, but we always should aim to create generic scripts that don't really like tell us what to do. We tell it what to do. So we could write a script that says find the player and follow the player. What we're going to do is instead we're going to say, no, we're going to tell you who the target is for this camera and you're going to follow that target. And to do that, up here we're going to create a variable. There's different types of variables in C#. Floats keep track of numbers, strings keep track of words. We're going to use a game object which keeps track of things. So in your game. So I'm going to say game object target. And then what we want is for this to be a setting, because if we go back in Unity and it loads in hopefully not too long, let's click on our camera already. We have a bunch of settings here already. Like in the camera component, we have the render type, the projection, the size, all these things here. We want to be able to create a setting like this. In fact, let's minimize all this to get it out of the way. Let's drag our camera controller onto our camera so we can start testing it out. You'll see that even though we created this game object target here, it doesn't appear as a setting. That's because it's currently private. In C#, all variables are private by default, so to make it public, we're just going to type the word public in before the word game object. A private variable is only able to be seen from within its own script, which means it's hidden to everything else, including the Unity inspector. But now that we've made it public, this variable is visible everywhere. Back in Unity, we can now see our target game object here. So we want to drag in the object that should be followed, the camera should be following, which in this case is the player. So I'm going to take the player object here, I'm going to drag it into here. Now, let's brainstorm what other things our camera should have as far as settings go. We should probably have a public float for our speed. A float is a number, like 1 or 2. It specifically allows you to create decimal numbers. So we're going to say 5f. This equal sign allows you to give a default value to a variable. This is not the value that's going to be used. This is just the default. If I go back into Unity, we'll see that by default, since the variable was created, it set our speed to 5. But if I set the speed to something like 2 here, that 2 is going to be the actual speed, not 5. Let's go ahead and make one more. We're going to make a public, this is going to be a vector 3 called offset, because we might want our camera to actually go a little bit above the player or a little bit up below the player, or in this case, we're going to move it on the z-axis so that the camera is not clipping into the player. A vector 3 is 3 floats, an x, a y, and a z. A vector 2 is only an x and a y. We want that z so we can control how far back and forth it is. If I switch back to Unity, you'll see that there's 3 floats here. This is like a coordinate grid with an x and a y, but in this case a z. Most coordinate grids you've worked with probably only had an x and a y. So x again is horizontal, y is vertical, and then z is actually back and forth, just so you know. These are all the settings we're going to use in this object. We're going to start now and actually write the code that makes it follow our object, which is going to be very simple. In our void update here, we're going to say transform.position equals, and then I'll show you a few different ways we do this. We could just say target.transform.position. Let's see what happens there. But first, a little bit of explanation. This is in void update because we want the camera to move every frame, obviously. What this would do is every frame, it would take the transform attached to this game object. So the camera's transform, which controls its position in this case. So it's going to move the camera's position to the target's position. So let's see what happens. We'll see that we can't actually see anything, which makes no sense. But if I go to the scene view, we'll see, oh, there's the camera, there's the target. Why can't I see anything? That's because if I switch from the 2D to the 3D view, you'll notice that the camera is actually intersecting with the target. The camera has a default like bounds where it's like, it can only see things within 0.0001 and 1,000 units away. So if it's less than 0.001 units away or more than 1,000 units away, it can't see the object. In this case, it's less than 0.001 units. It's exactly 0 units away. That's where our offset comes in. So we're going to say transform.position equals target.transform.position plus offset. And what this is going to do is whatever offset we set in Unity is going to be applied every frame to our camera controller. Back with the main camera selected, our offset here, I'm actually going to change it while the game is running so we can find a good value for it. Also so I can remind you about how changing values while the game running works. So let's say Z value here. If I increase it, we'll see it doesn't work. But let's try decreasing it instead. Because Z is actually, negative is actually closer to us and positive is further away. We'll see as soon as I change the value to anything less than negative 0.0001, we can actually see the player again. The standard is negative 10, so I'm going to type in negative 10 here. Now, the game is playing. You can always change these values while the game is playing. Like I can change the target to something else. But just know that when we stop the game, these values are going to be reset. So watch. The negative 10 changes back to 0. So if you make changes while the game is running, make sure you write them down because you might lose them. Okay, let's actually play the game real quick because this is actually going to work. Because again, every frame we're setting the position plus an offset now. So if I move the character, the camera follows. You can't really see because there's no other objects for reference, so I'll add something in to show you. Let's just add a square here, like a little wall. And now when I move, you can actually see that it is following the player. We just couldn't tell earlier because we had no context in our surroundings. Again, stop the game, it goes away. We want to make a camera that's maybe a little nicer to look at. This could cause nausea and honestly just isn't very polished. So let's make it a little smoother. Instead of setting our position every frame like this, what we're going to do is we're going to do something called a lerp. So before the target.transform.position plus offset, we're going to say vector3.lerp, and I'll explain what this does in a second. Say transform.position, comma, and then after the offset here, we're going to say, nope, we're going to say time.delta time times speed. Okay, what does this do? A lerp is short for linear interpolation. Basically, you have point A, you have point B, you have how far you want to go between point A and point B. So for example, I might want to go 50% or halfway between the points, or 25%, a quarter of the way between the points, or 75%, 3/4 of the way between the points. In this case, point A is our current position, and point B is our destination, or our target's position plus the offset. And then how far to go between the points, like 50 to 25% part, is this, which looks a little bit odd. We could just say 0.5, which is 50%, and what that would do is every frame it would move 50% closer. But what that also means is that if you run on a computer with a higher frame rate, void update's going to happen more often, and the camera is going to move quicker, which we don't want. So what time.delta time does is it actually gets you how many seconds elapsed between the current frame and the last frame. So on a computer with a really high frame rate, this code is going to execute way more often, but this number is going to be a lot smaller. And on a computer with a really, really low frame rate, this code is going to execute very, very less often, but this number is going to be a lot bigger. And what it does is it cancels each other out so that your code runs at a speed that's independent of your frame rate. After this, we're multiplying it by our speed variable so we can actually set the speed of this lerp. Let's go back into our code with our main camera selected, and let's see what this looks like now. Again, the goal is a smooth camera that feels more polished. We'll see immediately that it didn't just teleport the player, it smoothly went over. It looked really nice. Let's throw another box into our scene so we can see, for reference, how it moves. Let's throw 2 of them in. If I move the player now, we'll see the camera lags behind a little bit. The player is also a little bit shaky. There's a couple ways we can fix that, but this looks much better than before. And again, we can change these settings we want. Let's try setting our camera's speed to 1 instead of 5. You'll see it lags behind a lot more, which may or may not be what you want. Hopefully it's not, because it doesn't look very good. Try 10, and it basically locks on the player perfectly. This is still better than nothing, but I think 5 is probably a really good one actually. But use your own discretion, obviously. Now, as far as the player jitters, there's a few ways to fix this. Instead of update, let's try late update. This is the one they say you're supposed to use, but I haven't had a lot of luck using it, to be honest. Let's see. So yeah, I still get jitters. Let's try fixed update. You're not supposed to use fixed update. If you do use fixed update, you should change time.delta time to fixed delta time. And also, I'm gonna get rid of void start because we're not using it at all. If I run the game here, now this isn't supposed to work, but every time I do it, it works totally fine and it looks really good. So I just use it, but it looks good. So I recommend keeping it on this setting. And you'll see nothing. Well, I guess, no, it doesn't really jitter. No, everything looks really good this way. So I would keep the code like this and then get rid of this because it's no longer update. It's not fixed update. Like I said, only 5 lines of code, not very much. That's actually the whole video. That's the whole camera script. It works now, it works good. Now, I should have named the script something else because except for the name camera controller, none of this actually screams camera. Before we end the video, I'm actually going to rename it from camera controller to follow movement. We're generalizing it. We're making this code a little more reusable. In this case, just by renaming it, which doesn't actually literally do anything, but it kind of tells the user or the reader, the whatever, that they can reuse it. Our main camera now has this follow movement component, which is great. What if we wanted an enemy? If I make a little red square and I give it the follow movement, I set the target to our player and the speed to, we'll say 2, and have no offset here. I play the game now. this red square is going to follow me because that's what it's programmed to do. It has that follow movement script. Technically, it was a camera movement script, but we got rid of any like camera related terminology. I'm trying to throw in another wall here. I'm going to give this thing a box collider. I'm also going to give the enemy a box collider. Okay. Just to make it a little more clear what's happening. So again, didn't change anything about the script. I was just very careful when I made it to make it more generic. Oh my gosh, it's being out of control. Did I forget the enemy collider? It's not hitting the wall, is it? I must give the wrong square a collider. Whatever. Anyways. Oh, it's because it's made in the same position. This code won't work very well for things that need to have colliders because of how we're setting our position. There's a way to fix that. If you're interested, just let me know. But yeah, that's it for the video. And thanks for watching. Go ahead and watch another video.